Okay, this is chapter 8 of regular geometry. This is problem number 11. This is find the value of x in each diagram below, if possible. If the triangles are congruent, state which triangle congruency property was used. If they're not congruent or not enough information, make sure we're able to say that. So let's see what we got in this particular picture here. We know that these two lines are parallel. So that means that the alternate interior angles are going to be congruent, at least this one pair of alternate interior angles. So if this is 73 degrees, then this is also 73 degrees. I can't do the same with the 28 here and say that this is 28 because I don't know if these lines are parallel. And that causes a problem because we don't have enough information then to say that these triangles are congruent. So I only have one angle in this triangle that matches up with one angle here, and then one side that matches up with the one side here. So angle-wise, we're not able to do it. But if we take a little bit closer look here, we see that they share this side. So by reflexive property, that side is the same. So we have a pair of sides here at 7 that match up. We have another pair of sides that are shared, and then the angle in between is 73. So I would say that yes, these triangles are congruent by side, angle, side. And so even though we weren't able to use this angle of 28 to help us, we're able to show that those two triangles were indeed congruent. So now that they're congruent, I do know this is 28 because of CP/CTC, those parts have to be the same. And if this angle is x, then that makes this angle x. And so I can find what that angle is by using triangle sum theory. So 180 minus 73 minus 28. That is going to be our value of x, which ends up being 79 degrees. Okay, this next one, let's see, we have these two triangles. I have one side length here which is 9, which matches up with this side length here, that is 9. We can make vertical angles be congruent here, and then we also have an angle of 23 and an angle of 23. So at first glance it may look like these two triangles are congruent. We say, oh, we have two angles and a side, they have to be the same. Unfortunately, we have to look at where those angles are. For instance, on this triangle on the right, the side that is marked with a length of 9 is in between these two angles. But over here, the side that is marked as 9 is not in between those two angles. And so they happen to have the same angles, they happen to have a congruent side, but it's not in the correct location here. So therefore, there's not enough information to say that these two triangles are congruent. So therefore, we cannot just easily say, oh, well, if this is 6, then x is also 6. So we are not going to be able to find what that value of x is with what we're given here. Okay, the next part. Well, this looks like a 30, 60, 90 triangle, and this also looks like a 30, 60, 90 triangle. So we have two triangles that are both 30, 60, 90, and they both have the exact same hypotenuse. So I would say that these triangles are congruent, specifically by angle, side, angle. We have 30 and 60, the side in between is the same, 30, 60, the side in between is the same, so congruent by angle, side, angle. So that means that their side lengths are also going to be the same. So if the hypotenuse is 16, the short side is 8, which is that part right there, so we'll say this is also 8, and the long side is 8 root 3, which means this whole length here is also 8 root 3. So if we want to find x, we're just taking 8 root 3 and subtracting 8 from it. And that's how I'll leave my answer because I can't do anything there. They're not, like terms, so I can't combine them together. I would just leave it as 8 root 3 minus 8. This last one here, we have two overlapping triangles. They both share a right angle, so at least we know that's one angle that matches up between both of them. You can tell by these tick marks here that they each have a side length of 5. One of the legs of that right triangle is 5. And then they have another leg that is also the same. They share this part of 7, and then it's 2 on either side. So the leg in this triangle on the left is 2 plus 7, or 9, and the leg on this triangle on the right is 2 plus 7, which is also 9. So if you wanted to draw them out, these are horrible right triangle drawings, but you get the idea. They look something like this, which if we look at it, it's like a perfect example of a side angle side congruency. So I'd say these two triangles are congruent by side angle side, which means that this value of x here is the same as this value of x over there. But we run into a problem in that I don't know what any of the other angles are in this triangle as of right now. So at first glance it may seem like we're stuck because all we have is the 90 degrees and we don't know what these other angles are, but if we take a closer look here, we can use inverse trig to find what the angle is. So I'm just going to use, let's say x is like our theta, right? So I'm going to say the tangent of x equals the opposite, which is 9, divided by the adjacent, which is 5. So then x is just a matter of finding the inverse tangent of 9/5. And that we'd have to plug in our calculator. And so the inverse tangent of 9/5 is 61 degrees. So don't be so quick to give up if it looks like you're stuck. Maybe you don't have an angle. Remember, we can always use our trig stuff to help us out in that situation. If you have any questions or comments about any of those, please feel free to leave them.